Okay, so trying to use estimates. Now we know that you could plug these numbers into your calculator, okay, and raise 2 to the 0.3 power, raise 2 to the 0.9 power, find the points on your graph, do the fundamental triangle, find the slope, and there's your rate of change, right? Okay? But we're not going to use the calculator to do it, although it's just fine if you have time and want to come back and say, okay, there was my estimate, now let me calculate it, okay? That way, if you messed something up in your estimate, I might be able to give you a little credit for doing that, okay? So, as long as the picture kind of shows it. Okay, so, first of all, the inverse of the 2 to the x function, remember, you're going to reverse the points, the coordinates on the 2 function. So here's 1, you're going to go through 1, 0, goes 2 to the 0 is 1, okay? You're going to go through 1/4 -2. So there's 1/4, there's -2. You're going to go through 1/2 -1. Then you're going to go through
the XY thing, and then do
Zero.
the inverse afterwards. Like 2 to the 0 power is 1, so that would be your Y.
2, 1.
Make that the X.
and 4, 2. Now the
Yeah.
interval
Like the negative
that's
2
important here
to
is
negative
the interval between 0.3 and 0.9, right?
Yeah.
So 0.3 is a little more than 1/4, and 0.9 is a little less than 1, right? Okay? So if you sketch the curve, nice smooth curve, what do you want to do? You want to find the value of 2 to the x when x is 0.3. And again, you could use a calculator to do that. That's the only way you're going to find that, okay? You don't have any other way and you won't, okay? But 0.3, actually go back and look up some logarithm tables. Maybe there's the point where x equals 0.3. So that's what? What are the coordinates of that point? 0.3 what?
1.6.
Again?
1.6.
1 point what?
6.
Okay, it's negative 1.6, so you better be careful about that. But
You
yes.
said that.
And if you said 1.6
it.
and did all the calculations, that would be kind of a minor error, but you maybe get a negative slope where you should have a positive one, and I'd yell at you for that a little bit.
Like, how sternly though?
No more than 3 points.
You said so. That's 1.6 is. I mean, negative 1.6 is 2 to the point.
According to this graph, 2 to the 0.3 would be negative 1.6, and that's probably not far off. Okay? Maybe even negative 1.7.
I don't know how to use the calculator
Huh?
to put that in.
You don't need to know, but
Alright.
I'll show you anyway.
Alright.
Okay? It's just, actually, I don't know if I have one of those calculators. We'll look at that, okay? It's just 2 raised to the power 1.6. It'd be like 2 and then this thing and 1.6. Or not 1.6, 0.3. Okay, anyhow, using the graph, because that's all you're asked to do here. There's never any question, I don't think, where you have to actually put that into a calculator, okay? And later on, we'll look at, see how. So we have the point 0.9, right? And what's the y coordinate? Huh?
0.9 Y coordinate.
Well, here's the
Where's the
point.
thing? Oh,
Which is the point.
X coordinate is 0.9. If this is 1, 0.9's just to the left of it, right?
oh,
And what's the y coordinate?
0.1.
Y equals 1 would be up here.
Oh, I'm not looking there. Negative 0.1.
Negative 0.1, okay, I'm gonna go negative 0.3 though, because it's a little further down than negative 0.1. If you estimated negative 0.1, I would accept that, okay? I'm not trying to, again, get excruciatingly accurate estimates, okay? So, there we have it, okay? Now we want to find the rate of change, the average rate of change between these points, right?
Gotcha.
The average rate of change on the interval is the slope between the graph points. Now I could say that with a lot more words, but the more words I use, the more confusing the statement is. So I'm kind of going to say, you know what graph points would be the graph point for this value of x and this value of x, right? Because this is how you write the interval that goes from 0.3 to 0.9. So I can emphasize that. Here's your interval. Point 3, 0.9, and you know interval notation from the stuff we did with absolute values, okay? So there's your interval. Average rate of change in that interval is the change, average rate of change between this point and this point, right?
Yeah.
The slope of the graph between those points. So I say the average rate of change, according to my estimates, or our estimates, because we all kind of cooperated in messing up these estimates, is
Is that negative 0.6?
rise over run, right? Now also, you know, you really should sketch that triangle, label the rise, label the run. Another thing I would do is make this part of the graph bigger, because you don't even need this part, right?
No.
If you have these 3 points, maybe this one, so you extend your x scale out this way a little bit, use bigger increments for your x's, right? And maybe bigger increments for your y's. You could get a more accurate result, okay? Then, of course, that's 1.3 divided by 0.6, which is 2.16 repeat. Okay? If I did my quick arithmetic correctly.
Wait, where's the triangle? I can't see it.
0.6.